Okay, this is the tutorial for our section 1.3 in Math A30, and it's classifying linear systems of equations. And as you can see here on my notepad, I have the three, just a bit of a review here, the three types of linear systems that there are. There's the consistent dependent type, and this is two lines that are along the exact same path. That means that the slope of the line and the y-intercept of the line are the same or equal. So you'll have, if you look at the graph, one simple line laying on top of another line in the exact same spot. The other type of line that there is the consistent independent type. And this is two lines that have different slopes. That means that because their slopes are different, they will eventually cross each other. So a good example is like the X pattern that you see here. And they have one solution only. The other type of linear system is called inconsistent, meaning that the lines have no solution whatsoever, and that these lines actually have the same slope but different y-intercepts.
Gordon, telephone, Gordon. Sorry
about that. So in this case, I have an example of just a couple of parallel lines. They don't intersect. So inconsistent linear systems have no solution. Consistent independent linear systems have only one solution. And consistent dependent linear systems have the exact same solutions all the way because they're the exact same line. So what I'm going to do is I'm going to show you an example here that I worked out previously of how to classify each set of lines. So let's, I've got one example here on the bottom. I have line number 1, or A, I guess, letter A, x plus 2y equals 8. And the other one is 4y plus 2x equals 16. So what you would do is you have to think back to what your previous math has taught us about what we want to see in terms of the linear form of the line. We want to rearrange these lines in that form of y equals mx plus b, or the slope intercept form, where m stands for the slope of the line and b stands for the y-intercept. So that's what we're talking about here. So if you look at y equals mx plus b, that's the standard, the linear form of a line, where the m, the coefficient in front of the x stands for the slope of the line, and the b number stands for the y-intercept. So here I rearrange this one here by subtracting x from both sides, putting the x in front, and then dividing by 2 to get y equals negative x over 2 plus 4. Here I subtracted 2x from both sides, put it in front here, and then the 16, then divided by 4, and got the same result, y equals negative x over 2 plus 4. Because I have the same value and the same y-intercept value, we can then say that these are consistent dependent lines. And I'll move that up a bit because I've got it on the bottom there. Okay, so you can see that these are consistent dependent lines because they are the exact same slope and the exact same y-intercept. Okay, I'm going to move on to another example. Similar type of thing. Just going to flip over my sheet here. Let's make sure that that's centered. Okay, so my second example, let's say that I have the example that y is equal to x, let's say negative x plus 4. And then my second example will be, let's say 3x minus y equals 7. So again, I want to put it in the form of y equals mx plus b. So if this is already in the right form, so slope is equal to negative 1, and b, or y-intercept if you like, positive 4. So here I'm going to move the y over to this side. So I get 3x equals 7 plus y. Then I'll subtract 7 from this side. So 3x minus 7 from both sides equals y. So therefore, the slope is equal to 3, and the y-intercept is equal to negative 7. Okay, different slopes, different y-intercepts as well, but different slopes tells us that these are going to be lines that are going to intersect. Okay, if the lines intersect in one spot, okay, so these lines Okay, so for recalling what we knew from before in terms of our notes at the very beginning, if the lines are intersecting at one spot, we have consistent independent lines. And that's our little review for section 1.3. In the next section, or in the next part, I'm going to stay in section 1.3 and look at an example of one other type of question that you will solve in this area. That'll be next section.